Good morning, ladies and gentlemen of Algebra 2 Honors. Good to have everybody here today. We're missing a couple people. They'll be back on November 30th. Anyway, we're going to start our next section, which is adding and subtracting polynomials. And so we're going to start out today going over some vocabulary and a couple little things about polynomials. Essential question: how do you add or subtract two polynomials, and what type of expression is the result? So we're going to go over some basic vocabulary at the beginning here. So adding and subtract polynomials. And this first section here has to do with identifying what is a polynomial. And a polynomial function of degree n has the standard form, and this is sort of a complicated way of describing what ends up not being very complicated, and you've seen that before. And each term of a polynomial is called a monomial. How do you decide how many terms you have in a polynomial? The terms are the things that exist between the plus and minus signs.
Oh, yeah.
Okay, so that would be a term. So this would be a term here, and then separated by this plus sign, that's another term. And you could have minus signs separating, but a minus is just what? It's just adding a negative, essentially, is what that is. And then it talks about a polynomial is a monomial or a sum of monomials. And here we're getting into some other vocabulary. The degree of a monomial is the sum of the exponents of the variables. And usually with a polynomial, there's only going to be one variable, which happens usually to be x, right? As we have, if we have a standard xy coordinate plane.
What's monomial?
Well, a monomial, it says a monomial is the product of a number and one or more variables with whole number exponents.
Okay.
So that's a good refining question, Marcus, because these exponents here can only be positive whole numbers. They can be 0, 1, 2, 3, 4. It cannot be a half and negative 1/2 and so on. And so that's a very good refining question, Marcus. Appreciate that. And then another thing, there's something called a degree of a polynomial. And the degree is the degree of the monomial term with the greatest degree. And the leading coefficient of a polynomial is the coefficient of that term with the greatest degree. Usually you'll write in standard form monomials with their powers in descending order from the greatest to the least. So that's the standard form. And so this n would be, if this is a third degree polynomial, this could be like 6x to the power of 3. And then the next one would be the x squared's place, the x's place, and finally the a sub 0 is going to be the constant term at the very end. And so you're going to have that succession of hierarchy. And in addition to the leading coefficient, there's a nature of a polynomial that has to do with the question, is that leading coefficient a positive number or a negative number? And we've dealt with this already, haven't we, when we had quadratic functions that opened up or down depending on negative or positive, right? So just a few things, and we're going to be going over these today. Do you have any questions or observations on those right now? So you've been exposed to this a lot already, and even a linear expression is a polynomial, right? Like 6x minus 5 or something like that, linear. Okay, now we're going to do a couple little exercises here. Identify the monomials, and you have these expressions here. And I don't even want to list these from here, but let's just go ahead. Identify the degree of each monomial. Well, x to the third power, what is that degree going to be? Yeah, the degree is going to be 3.
Yeah.
Okay.
Yeah.
And then as far as this term here, a squared times b times c to the 12th, what's the degree of that one?
14.
The degree is actually going to be
15.
yeah, it's going to be 15. Thank you, Marcus. Yeah. And so you add up. Now, usually you're just going to have one variable in a place of a monomial, but you could possibly, like this instance, have a squared times b to the first times c to the 12th, so 15 total. And then 76 is going to be a monomial of what degree?
1.
It's actually going to be to the 0 degree, because what it is you go all the way to the 0 power, so this is going to be 76 times x to the 0 power, and x to the 0 power being 1, and so the constant means to the 0 power, essentially. And then here it says on this row it says identify the coefficient of each term, which is like the number associated with it. So how many y's do we have here? 1. So what's our coefficient? 1. And then we have, what is our coefficient of this next one? 3, -5, 10. And then as far as identify the degree of each term, so now we're going to take the same thing. What is the degree of each term?
Would be 1.
Degree is 1,
2,
2,
3,
3,
0.
0. Okay.
I can't even see that.
Pardon me?
Why is y 1 instead of 0?
Why is that? Okay, that's a good question. We're finding question, Haley. Okay, it's because it's y to the first power. When you see a variable just isolated by itself, it's going to be to the first power, and so it's just like Marcus pointed out with this one up here, this one here being a 15-degree monomial here, because you have a squared, b to the first, and then c to the 12th, and adding up all those separate powers comes to 15.
Yeah.
All right? Are you okay with that? Okay, good. And then it says write the polynomial in standard form. And so here we have this polynomial right here. How do we write this in standard form? Well, we put this in descending order from the greatest power to the least. And so we look at this. This is the third power. So that's going to be our first thing we go out here like this. So -5y cubed, and then we have, what's the next one?
3.
Plus 3y squared, and then we have plus y plus 10. And then the final question here, what is the leading coefficient of the polynomial?
-5.
It is, as Marcus says, -5. And what happens is that in the overall scheme of what's important about a polynomial, this leading term is the most important thing. And why is that the case? Well, the reason that's the case, because this is the highest power, it means that the end behavior nature, the negative, positive, whatever else the rest of it happens here, eventually this first leading term is the one that's going to take charge and rule the end behavior and the main characteristics of that polynomial function, if it turns out to be a function, which is what we use it for. Okay, questions on this page here? Okay, does this connect with with any understanding you have at this point in your mathematical career? Should at some level, right?
A little bit.
A little bit. All right. How can you find the degree of polynomial with multiple variables in each term? And so this question was the one that was really answered by what Marcus was telling us a little while ago when he made this this one right here,
15.
a degree of 15. So that's.
Those numbers.
So anyway, the first thing we're going to talk about is adding. We're going to talk about adding and subtracting polynomials before we get to our exercises. And when we add polynomials, if we take like example A, you have this polynomial here, 4x squared minus x cubed plus 2 plus 5x to the fourth power, and we add to it this polynomial right here. What you can do is you can stack the like terms. Okay, that's another thing. Like terms. Like terms are going to be what? What are like terms going to be?
X squared.
And that's the same letter.
Pardon me?
And that's the same letter.
Well, not only same letter, because Haley just said the same letter,
Same
but
letter and variable.
same letter, same variable, but to the same power.
Yeah.
There you go.
Okay, to the same power. So yes, those two things. So those would consist of like terms, and you've talked about that a lot. So what I'm going to do is just go to this. Okay, then reflect. Is the sum of two polynomials always a polynomial?
Same
No.
X cubed.
Yes? Yeah, it is. Why is this going to be always the case? Yeah, because if this thing here qualifies as a polynomial, any other polynomial we add to or subtract from is still going to qualify as a polynomial, right? No matter what. So that's the question. Now, what I'm going to do is briefly just add. I'm going to go over an addition problem here, and here we have these two polynomials that are separated, that are cordoned off in sets of parentheses. And so what you're looking for is you're looking for like terms. And so what I'm going to do is I'm going to take this like term here
1980.
with I see this is in common with the x. This is the x cubed term here. So right underneath it, I'm going to put plus, I'm going to go like this, plus, I'm going to put 11x cubed right underneath. Does that make sense to you? Okay, so it's like we're making up columns of like terms. And that's, do you always have to do that to understand how to add and subtract polynomials? No, you may not necessarily have to do this,
But it's better.
but it sort of depends on how much space you have, how familiar you are with it. Next thing we have is this negative 8x squared, so I go ahead and put this right under the x squareds like this. And then lastly, we have this 12 right here. So I see we have this. I can put plus 12 right underneath this 4. And so have all the like terms been accounted for here?
Yeah.
Yeah, so let's go ahead and move the columns down. So here we add to 17x to the fourth power 0. So we just bring down 17x to the fourth power. And then here we have
Cancel.
8x squared minus 8x squared, so that's going to be what?
Cancel.
0.
They're going to really cancel, so I'll just put plus 0. And then we have this minus, we don't have anything below there, so we put minus 9x to the 7th power right underneath. And then 4 plus 12, 16. And then negative 2x cubed plus 11x cubed
9x.
plus 9x cubed. And then as a last thing here, what I'm going to do is just rearrange this polynomial into standard form. And how do we organize that?
By letters and exponents.
Negative 9x.
Yeah, so Marcus pointed out, right, it's going to be negative 9. That's negative 9. That's a 9, okay. X to the 7th power. And then what's the next one?
17x.
Okay, plus 17. X to the 4th power. And then we have, the next one is 9x cubed. And then we have just plus 16, right? Okay, so really that's it. Does that look like is that bad? Let me give you another one here. What I'm going to do is we're going to go right over into subtracting polynomials. And I'm going to get over right to this, your turn, subtract the polynomials. So basically for this one here, it presents some more challenges than with just adding polynomials, because with subtracting, it's easy to get the signs confused if you're not careful about it. So what I like to do is the first polynomial in parentheses here, I'm just not going to worry about that at all, because that's what we're subtracting from. So that's in good place. But for the second one here, what I'm going to do is we're going to distribute this negative sign. So it's the distributive property, right? And so we have negative 9 to the 4th power is going to be what? That's going to translate into plus 9x to the 4th power. Does that make sense? And then negative times 6x squared is going to be minus 6x squared. And then finally we have negative 31, so that's going to be plus 31. And so I find it's helpful to do this little translation with the subtraction problems, especially when there's a negative sign, because the negative sign, if it's a positive sign, that's not going to be much of an issue, right? So now we can just stack these things right underneath, and then what can we do with these stacked things underneath? Okay, I'm going to put, we have 9x to the 4th, so I'm going to put plus 9x to the 4th right underneath that one. We have negative 6x squared. Do we have any x squareds here? No, so I'm going to put this negative 6x squared kind of outside, since there's no column for that yet. And then finally we have this 31. Where's that going to go? Plus 31. And so now what we can do is, since we've already worked out all the signs, we've turned this into now an addition problem, right? So we did the hard work up here converting the signs properly, and we've turned this into a basic addition problem at this point. And I find that just keeping things straightwise, addition, if you can boil it down to that, is going to be less prone to give you mistakes. So now we can just add. Well, if we just add column by column, we have first negative 6x squared, and then we take this column here, so it would be plus 23x to the 7th power. And then this next column, we have negative 9x to the 4th power, plus 9x to the 4th power. So that would be plus 0. And finally, 1 plus 31, 32. And so now what we have here is our final answer in standard form is going to be 23x to the 7th power minus 6x squared plus 32. Now one thing, I don't know if I've seen people do this. I spent some time over in France and Belgium a long time ago, a couple of years, and what happens is that over there, they will write their 7s like this. You do that? Yeah, this is really more of an engineering way to do that. One thing over in Europe, they make their 1s sort of like this anyway. Have you seen them write 1s like that? Yeah, they kind of write their 1s like this, which almost looks like a 7.
Look like a paper.
And so when I was doing in my engineering career and all that, I would write them like Haley all the time. I don't do that as much anymore, but that's one of the things that can help you keep straight. Another thing that you have seen me do is whenever you use Z, to go like this, because otherwise a Z will possibly look like a 2.
Mr. Griffin, Mr. Griffin writes his zeros with the line through it.
Yeah, so that's another thing. Another thing to distinguish between an O and a 0. Okay, so people will write that. I have not done that in my career, but that's something. Because usually when you put a 0 placeholder, you'll usually be able to pull it out in context, like the letter O would make no sense here, right?
Yeah.
So there's some different ways, different articulations of that, but just be aware of those. There's a good reason for all of them. And what I want to do now is we're going to start on a sheet, exercises on that. Just start on that. I don't know how far we're going to get. All right. Here we go. Facts. He said facts.
Yesterday.
Tomorrow?
Tonight. The baby's house.
Tonight.
Randy.
Okay.
Got this, Mark. I got this. Mine.
I don't know how far we're going to get in these exercises today. Probably not all the way through them.
We're gonna get far.
But
Right, the polynomial.
this one here,
That one's easy.
yeah, this one is pretty. I think I'm going to call on somebody for number 1. How's that? Can I call on somebody for number 1?
Go ahead.
Yeah.
Easy.
I think it's good because we went over that pretty well. I'm going to shuffle once and go ahead.
Let me get it out the living room.
Yeah, it's gonna be Randy.
It'll be Marcus. All right, Marcus was helping us out a lot anyway.
Yeah. Martin was up.
So
I
Marcus.
already knew this.
Didn't that happen earlier?
All right, Marcus, what do we got here?
X9 minus 23, X7, minus 6, X3, and then plus 2, X2, and then plus 10.
It's 2x squared.
Shut up.
So is this a good standard form
Perfect.
explanation of that? Okay.
Absolutely.
Okay, great. Next, what would be the degree and leading coefficient?
1.
Can't really see these very well.
Yeah, they're looking kind of hard, but
Oh, you got a
I'm
paper?
trying.
What is our degree of this thing here?
1.
No, it's not 1.
degree?
Degree?
That would be 9 plus
9.
7.
It'd be 16, 19, 21,
21.
and then it's 21.
21.
Okay, your answers to these last two are all embodied right in this thing right here, which is called the leading term. This is what is used to answer this. So what is going to be the degree of this?
9.
9.
He gets better.
And what is going to be a leading coefficient?
1.
It's going to be 1. 1x to the 9th, okay?
9 plus.
All right? So that's really the only problem like that. And those of you, most of you, I hope, pre-calculus next year, we're gonna go over that again.
Are we doing the terms? The 9, 7, 3, 2? What is it?
Well, in terms of what we're instructed to do, we've done that all here, okay? So those are terms that are not leading.
Yeah.
So that's that, okay?
I think you're confusing, should you?
Okay. Let's go on. So next, adding polynomials here. Should I just spin the wheel on this one? You're gonna work this one out, I'll spin the wheel on it in just a minute.
That's been the word.
Go ahead.
Let's just work on it first for a minute or two,
Alright, bet.
then I'll work with somebody here.
Alright, bet.
And while you do that, I'm gonna go erase other stuff here we put up.
What's 21 minus 42, Ziggy? What's 21 minus 42? It's gonna be
42
negative,
minus 21?
negative 21? Right.
Yeah. That's right, Mark.
Okay, I've erased everything.
5, no, wait.
What are you doing?
89, that's.
Will we put it in standard form?
Yeah, okay, that's another thing. Marcus just asked another good follow-up question. Yeah, I want you to go ahead after you add these together to render them in standard form, if you could.
What you got, Mark? That's wrong.
You finished number 2?
Number.
For a steak.
Number 6.
Lick it.
Yeah, look at
You lick it. This. No. Right.
Okay, let's go. Shuffle wands, here we go.
It's gonna be Braden. Alright.
Or
It's gonna
Haley.
be Haley.
You're not here? She's not here.
Should we just wait for her?
Nah, choose someone else.
Get somebody else.
Just put close.
She'll do the next problem.
Yeah, I'll go. We'll choose her again, maybe.
Yeah.
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 Hey,
Cheyenne,
Cheyenne,
Nick.
this is you, Cheyenne.
Oh, man, I thought it was gonna be me.
Come on, Vic.
All right, Cheyenne the lefty, Cheyenne the lefty. Okay, Cheyenne the lefty, what do you have here?
Basically add them in the 18x, or you can do 82x to the 8 plus 21x squared minus 6.
So did you put them in columns? You didn't? Like I showed the example, put them in columns, you didn't do that?
Yes, that's what I mean.
So where do you want me to make the columns? On the right here or to the left? To the left, okay. So 18x, does that have a column existing already? No, so I'm put this over here, how's that? Is that okay?
Yeah.
And then this next one here, where does that go? Right here? So plus, put this right underneath here. So 7x to the 8th, okay, that looks good. And then this negative 42x squared,
That is under the 21.
plus 3. And then you added all these?
Right.
So you get, so 18x here
Plus 89.
plus 89x to the 8th.
Minus 21.
Minus 21x squared and minus 3. Okay, and that's gonna, and then you put that in standard form?
89x. Minus 21x squared. Plus 18x. Minus 8.
Okay, any questions on that? That's what you got?
Oh, you did?
You can test these answers too, and there are ways to do that, but I don't want to talk about that right now. Kind of gets tested with the calculator. Any questions on that one? Okay, I want you to go work on number 3, and I'm going to spin the wheel again for number 3.
The exponents, you can't see them.
Can't see very well in the paper. Okay, so I got to.
I already do like more. I just want to cross
I
it
have
out.
to advance.
Cross it out. I don't even do that.
I'm pretty sure I'm in the last one, that's 7.
Okay, let's go ahead. Yeah, it's one thing, the graphics that you have on your paper are not as apparent. So this is what you have for number 3. Does that make, is that the way you see it on yours?
The 7s are blurry. sort of.
7s are blurry on yours? Okay, but you know what they are now, right? Okay.
See some more. Yeah. Is that a 9?
One thing I can possibly do,
Plenty of you were gone, so.
Lucky.
Not right, yours. Good job, okay.
one thing I can do is I can go back to the worksheets and see if I can expand those graphics a little bit, because that's possible.
I should do my ace word. I should do my ace.
Boy, did you get that high.
I'm halfway done. But
Wait for your license or permit?
license.
Okay, ready to go?
I still need to work from it. What did you do? Big appointment to like next.
Here we go, next person here.
Then I gotta wait 4, whatever.
I think it should be me.
6 months.
I think it's gonna be me. Yep.
It's
I'll
like
be-
May.
Yeah,
It's a run.
at least.
At least. Come on, at least.
Okay, at least.
Okay,
At least.
I'm gonna turn the right side over to the left side and column.
So you're gonna take this, all these terms here and put them underneath here?
Yeah, so I
Okay, good.
put the negative 9x, I mean x to the power of 9 over that one. Yep.
Yep.
And after that, I put plus x to the power of 7.
Right here?
Yes, and then minus 68x squared. Right after the x to the power of 7.
Oh, right here?
Yes.
What would that equal?
And then I got, well, okay, I have 2 more things, so don't, so I got 15x minus 121.
So you went and added these now at this point?
Yeah,
Okay, so 15x,
minus 121x to the power of 12 minus 65x squared.
so these will zero out here?
Yes, those cancel out. And then I got 121x to the power of 12.
You know you can increase them, right?
Oh, yeah, negative 100.
Negative out front here?
Yes.
Okay.
And then minus 65x squared plus 15x.
Okay?
Yep.
And just as a follow-up, what's going to be our degree and leading coefficient of this thing?
Our degree is going to be 21.
12.
12, what? Where'd you get 21 from?
I don't know.
She got the two numbers.
12.
Yeah, you got the.
And what about our leading coefficient?
Is it going to be negative 121?
Negative 121 is our leading coefficient. Okay, good. Good job. Okay,
Apparently, sit over here.
so let me go ahead and get the graphics up on the other one too, see what we have here. Okay. You can see that okay?
I guess.
Your paper?
I guess so. I hope so.
And I'll choose somebody else here. That might take us to the end of class today. We're running out of class time.
Yeah.
Did you think class went by pretty fast
It
today?
went quick.
Oh, yeah.
Yes.
Pretty good.
It went quick. Ready for the break, Mr. G.
Yeah, our break is coming upon us.
You know what I'm
Our
doing?
last day until Thanksgiving break.
I'm gonna party.
And I'm ready to go out of town.
Me and Allie are going out of town.
Yeah, we're going to Kansas.
Kansas, wow.
Yeah.
That's where I was born, Mr. G.
You were born in Kansas?
Kansas City.
So you were born in Kansas just like Dorothy.
Yep, I'm not in Kansas anymore.
All
All right, let me go ahead and spin on this one.
You were raised in Kansas?
Not that one. 2 years.
2 years?
4.
Okay, here we go.
You said 2 years?
Ready to
2
1.
years.
You're a fraud.
Okay, Bryce, you're the guy, Bryce. All right, Bryce.
Bryce.
Alright. Okay. I took the left and put it on the right side.
There you go.
So Bryce took the left and put over the right. Can you actually do that?
Nope, nope.
Yes, you can.
Yeah, with addition. Now you got to be careful when you subtract, but if you do that, you can do that. So Bryce, let's go ahead and do that.
Gonna do the
I
rest.
put the negative x2. I mean, to the power of 2. Under the negative 18.
Like this one here.
Yeah.
Yeah. And then I put the 16 under the bottom. And then I added. And
Okay.
I got negative 20 to the power of 2. Oh, what is it? Oh, never mind. My bad.
Okay.
I added the 2 instead of
And then we have, bring down this one.
What's going on over here?
Give me a second. Okay.
And then,
I got that.
then this last one
I got 20.
goes 21. Okay, and then the last thing, put this in standard form.
I got 7. I got 7x to the power 5 minus 10x to the power 4 minus 19x to the power 2 plus 21.
Okay, looks good. Now, what is going to be our degree and our leading coefficient for this thing?
Our degree is 5.
Degree 5,
Our leading coefficient is 7.
leading coefficient 7. All right, good job. We'll leave it there.